start with a generic polynomial function. F of x equals a plus bx plus cx squared, and so forth, going on and on as long as we need it to. We can take the derivative, follow through with what we know about derivatives of polynomial functions. F prime of x, a, derivative of a is a constant, so that's 0, plus derivative of bx is b, the derivative of cx squared, 2cx, and so forth. What if we want f of x to equal f prime of x? Then b would have to equal a. It would also equal 2c. c would be 3d. d would be 4e. e is 5f, etc., etc., and so forth. Simplify. b equals a. c equals a half of b. d equals a third of c. Okay, one more step. b equals a, c equals a half b, which equals a half a. d is a third c, which is 1/3 of a half a. e, a quarter d, is a quarter of 1/3 of a half a. And f is a fifth of e, which is 1/5 of a quarter of a third. So we get a pattern. Now let's choose a convenient value for a. a equals 1. This gives us f of x equals 1 plus 1x plus a half x squared plus a third times a half x cubed, and so forth, as far as we like, up to x to the power of n. And then what's over here, let's just put it underneath, it's going to be n factorial. So this is a function which is its own derivative. Take this derivative and see if you don't get the same thing. Now what if we evaluate at f of 1? We'll get 1 plus 1 plus 1/2 plus 1 over 3 factorial plus 1 over 4 factorial plus, and so on. And we can write this as 2 factorial. Let's put a 1 factorial under here and put a 0 factorial under here just to be complete. Each additional number gets smaller and smaller, and this whole thing approaches a value of about 2.718, on and on and on, which you may recognize as the infamous e. We'll show later that this f of x is actually the function e to the x, and so f prime of x is also e to the x. When that video's ready, that will be here. Here's the whole playlist. Bob is your uncle, and cheers.